Zero molding is integrated technology for reducing loss, defects, and faults as near to zero as possible. Simple in setup, overall machine accuracy, stability, and productivity have also been improved. Zero molding consists of 3 separate technologies: MCM, FFC, and SPS. MCM, together with center press platen and clamping force closed loop control, ensure best mold clamping control. FFC controls resin flow during filling so as to ensure smooth, complete, and balanced cavity filling under optimized pressure. SPS is operability-related technology that facilitates setting work for MCM, FFC, and other features. Let us show you how zero molding is actually set up by following the standard procedure. The machine used in this example is the SE100EV. The molded product is a component made of polypropylene and molded using an 8-cavity mold. First, install the mold. Follow the steps 1 through 5 on the mold mounting screen. The entire procedure is displayed on a single, easy-to-understand screen. Next, detect the minimum clamping force. Turn number 6 minimum clamping force detect on and press the action button. Minimum clamping force detection starts automatically and ends in about 90 seconds. The detected clamping force is the minimum required to completely seal the parting faces of the mold. Treating this value as the minimum, reduce the clamping force to the extent possible so as to prevent burrs. The results of this clamping force can be judged from the waveform, in addition to how the molded product looks. The graph on the right indicates the mold is forced open by the resin pressure. In this case, the clamping force is too low. The control of filling pressure that FFC enables can greatly reduce mold clamping force. In this example, molding is accomplished at a clamping force of 100 kilonewtons by a 1000 kilonewton class machine. Continuing, we set VP changeover point and flash time using the short shot method. The basic process is to fill cavities somewhere between 80 and 90% by setting the VP changeover point. Then, fill the rest with flash control. Adjust gradually the VP changeover point to the front end of the screw from a point that obviously will result in a short shot while watching the molded product. Molding conditions are displayed on the Z screen. To begin, the VP changeover point is set to 25 millimeters. The flash time at this point is 0 seconds. Next, the VP changeover point is set to 18 millimeters. Next, the VP changeover point is set to 15 millimeters. With further tuning, the VP changeover point is set to 14 millimeters. Next, the flash time is set when cavities are judged to be about 90% full. The initial flash time is set to about 1/3 of the filling time, which in this case is 0.24 seconds. Next, the flash time is set to 0.48 seconds. And ultimately, the flash time is set to 0.70 seconds. With the VP changeover point of 14 millimeters and flash time of 0.70 seconds, all cavities are evenly filled. If the VP changeover point is too short, burrs form because of the high filling pressure. To ensure cavities are evenly filled under low filling pressure, filling is done under flash control, which is based on the viscoelasticity of the resin. Let us compare the waveforms for when flash time is set and when it is not. When flash time is set, it is seen how the screw position is controlled during that time. The waveform of the detected holding pressure dips slightly because of this. Cavities are filled with resin during this time. This is a comparison between molding with zero molding and ordinary molding. In ordinary molding, burrs form on the parting line when trying to completely fill cavities with a clamping force of 100 kilonewtons. When clamping force is increased to prevent burrs, defects like short shots occur because gas cannot adequately escape. With zero molding, all cavities are evenly filled and no burrs have formed. SPS is operability-related technology that optimizes the interface. Setup can be completed smoothly without mistakes, even by unseasoned engineers. Let us compare the setup procedure from setting up conditions to purging against a conventional controller. The count shows the number of times buttons are pressed. With zero molding, less buttons are pressed, and subsequent operations are displayed on easy-to-understand screens. MCM for high-precision clamping at low force. FFC for smooth, complete, and balanced cavity filling under low pressure. And SPS setting for simple, mistake-free setup. You should definitely try zero molding as a way of revolutionizing your molding technology and improving your production efficiency.